This module covers Domain Name System, or DNS, and it's going to be broken into a number of lessons that review how DNS works and to a more detailed level of the types of queries that can be performed from a DNS client to the server, and also how the DNS server actually works. We're going to look at the types of DNS zones that are available and some advanced configurations that are useful in very large enterprises, companies that have acquisitions of other companies, and really just streamlining DNS operation. We're going to look at some of the more advanced types of record available in DNS, and also how we might manage them, particularly when we use features such as dynamic DNS and records are created automatically, but we want to make sure they don't linger too long in the environment. Then we're going to look at some DNS troubleshooting options. So firstly, the DNS namespace is a hierarchical. There is a root, and then from this root there are a number of top-level domains, such as com, net, org, edu, etc. Then there are second-level domains, such as Savaltech, Microsoft, and they are a child of one of those top-level domains. So savaltech.com, microsoft.com, savaltech.net, for example. And then within those second-level domains, there might be subdomains. Could be northamerica.savaltech.com. It may contain records such as webserver01 and alias records, which is really just another name for an existing CNAME or hostname record such as www. And the way this works is for each of those different levels, there are one or more DNS servers that are responsible or authoritative for that portion of the namespace. So there are root DNS servers that know where should it point to for com, who should it point to for net, who should it point to for org. And basically it delegated that portion of the namespace to those servers. So the com namespace has been delegated to the DNS servers that are responsible for com. And then from com, it has delegated namespace for Savaltech to the DNS servers for Savaltech. And the DNS servers in Savaltech contain all the host records and maybe details of subdomains for that part of the DNS namespace. When we look at a record such as webserver01, its fully qualified domain name contains its entire name of that hierarchy. So webserver01.savaltech.com. Now the way DNS actually works is I have a DNS client and it makes a request to its local DNS server. This will be the DNS server in your organization. And if that server is not authoritative for that zone where that record would exist, for example, I'm searching for www.microsoft.com. Well, my DNS server isn't a DNS server for Microsoft.com. It's a server for savaltech.net, for example. So it has to find out, well, where is www.microsoft.com? And it uses a process called recursion. So basically, it makes a iterative query to the root name servers. So remember, these root name servers can tell someone querying, well, where do you need to go if you need to look at the com portion of the namespace? Or who do you need to talk to for the net portion of the namespace? So the DNS server performs an iterative query to the root servers saying, how do I get to www.microsoft.com? The root servers return a response saying, here's how you would get to com. So it gives it the DNS servers for the com namespace. The local DNS server then asks again, how do I get to www.microsoft.com? The com servers return, well, here's how you get to microsoft.com. So that's another iterative query. And then finally, my local DNS server now knows the DNS servers for Microsoft.com and can say, how do I get to www.microsoft.com, or in this case, savaltech.com. And then my DNS server returns that result to the person who asked, that DNS client. Now there's two types of queries going on here. These are iterative queries. So from the DNS server to each of these other servers, iterative query basically means I want you to answer this with just the information you have. So it's either going to be able to give me an answer for part of the name, or i.e. a referral, or it's going to say I can't respond to that. And it's doing this in a recursive function. So this can get confusing, but essentially each of these is an iterative query saying just tell me what you can using your own information, which is why the root server just basically returns referrals to how to get to com, while the com server just returns referrals on how to get to savaltech.com or microsoft.com. So these are iterative queries. The client is giving a recursive query. So that basically means I just want you to give me the final answer. Now that is confusing because obviously it's a recursive query, but it's not using recursion. The DNS server is actually using a recursive process to find the answer for a number of iterative queries. So try and think of it as basically the client is giving that DNS server permission and it's asking it to, hey, do this recursive query for me. So then that client is just going to get the final response. And you can actually see this in your own environments. So this is my local machine and I can go into NS lookup. So this is a standard tool for how I can query DNS. Now typically, if I just typed in www.microsoft.net, it's giving me an answer because I made a recursive query to my local DNS server. And so it went through and it made that iterative query to the root servers, then to com, and then to Microsoft.net. So it did all that for me. And notice the answer is non-authoritative. This is because my local DNS server does not contain that zone. So it's a non-authoritative answer. If I asked it for a record that it was actually hosting the zone for, notice it doesn't say non-authoritative. It's authoritative for that zone. It hosts it locally. So these are basically recursive queries to my local DNS server. But I can turn that off. I can say set no recurse. So now when it makes a request, it's going to say do not do recursion on my behalf. This is an iterative query essentially. So just give me the information you have locally to try and help me on my way. So now if I search for, let's say, microsoft.co.uk, so it needs to be something that's not in the cache because DNS servers will also cache the lookups they've performed to avoid them having to do it again. So if I just did www.microsoft.net again, it would be able to service it from that DNS server's cache, which really wouldn't be much use to me. So I type this in. And now look what it responded to me. It didn't give me www.microsoft.co.uk. All my local DNS server is able to do for this address is to point me to the root servers. That's the best it could do. Now I, as the DNS client, would now go and set my name server to one of these and now ask it again for www.microsoft.co.uk. And it would point me to the UK servers, then point me to the co, Microsoft, etc. So you can see there the difference. If I set this to recurse back on, and do that same query again, now it gives me the answer. My DNS servers went and did that for me. And again, you can see it's still non-authoritative. If I actually go and look at my DNS server and I do a refresh, you can see here the root, it looked up UK, co.uk, Microsoft, and it's now cached that www value. So this is why, even if now if I ran that query again, so if I jump back to my client and I set no recurse, so remember it's saying only answer this with the information you have locally, it can still answer it. It's in its cache. But if I cleared out this cache and run it, now it has to point me back to the root servers. It doesn't have that answer anymore. Now in reality, my server won't always have to try and do that full recursive process with all those separate iterative queries, because you can configure forwarders. So in this case, especially in my environment here, I have an ISP. And rather than me doing all those iterative queries, I can say when I have a request, I want you to send it to the DNS servers up the chain. So I would then ask them, basically I would be making a recursive query to these servers saying, please give me an answer. And I want those external DNS servers to do all the work for me. Now, if my forwarders aren't available, then use root hints, use that standard process. And here I can see those root hint servers that I'm actually going to go and query if I have to. Additionally, I can do that conditional forwarding. So imagine a scenario where I did acquire another company. Saviltech.net acquired widgets.com. Rather than having to go out to the outside world, the root servers and com, I could say, if you want to talk to widgets.com, I could just create a conditional forwarder for widgets.com and I would type in the IP addresses of those servers. So this would actually now enable me to directly go and query the DNS server that I specify for this domain. And because you're actually specifying a specific DNS server, this lets you control the exact server you're talking to, so you can control which firewall ports you may need to open, port 53, between my DNS server and that target DNS server. And remember, if you are trying to do as firewall rules, DNS actually uses UDP, not TCP typically. But you may want to enable both because there are different types of DNS traffic. So sometimes it will use TCP. So generally enable port 53 for UDP and TCP. So that was just showing you the other ways the servers can actually communicate to external DNS servers and maybe other DNS servers internal to your organization that have a completely different namespace. This concludes the lesson on the review of DNS and the different types of DNS query and response.